डॉक्टर साहब ज्वाइन कर लीजिए। रौनक, वी कैन स्टार्ट।
Okay, sir. Sir, am I audible?
Yes, yes, you are very much audible.
Okay, sir. So, a very good evening, everyone. I, Rona Gupta, Webmaster IEEE Women in Engineering, warmly welcome you all to the sixth day of this faculty development program on electric vehicle power station simulation using MATLAB and real-time simulator. I would like to extend a heartfelt welcome to Professor Sanjeev Kumar Sir, Coordinator HRD Cell, Convener FDP, Professor CN Singh Sir, Coordinator of this FDP, Mr. Ashutosh Yadav Sir, Co-Coordinator of this FDP, along with all the distinguished faculty members present here. For our final sessions today, we are privileged to welcome respected Mr. Shivam Srivastav Sir, a renowned expert in real-time simulation and hill testing. Sir did his BTech in Electrical and Electronics Engineering 2016 from Anand Engineering College, followed by MTech in Power Electronics 2019 from GLA University with a distinguished grade of 8.27. He is currently an application engineer at Quartz Info Systems, specializing as a Typhoon Hill expert. He brings over 4 years of academic experience as an assistant professor at IIT Khandari and Sachdev Institute of Technology. He is also a highly certified professional, including Hill Specialist 2.0 and expert in test automation, microgrid, and communication protocols. The first session will be on the topic Introduction TIC 2000 Toolbox Package. So, now I kindly request Sir to take over the session. Sir, the virtual stage is yours. Please continue, sir.
Thank you and very good afternoon to all. And into today's session, I'm just going to just present the TIC 2000 toolbox. I hope I am audible to all.
Yes, yes, you are very much audible.
Okay, so let me just share my screen so that the other participant can get the view how the things are going to be happen. And before starting the thing, I would just like to just ask you all that whether you are facing any of the technical query related to the whatever the previous sessions held by the Typhoon team member.
Yes, if anyone having any problem, the session delivered by Ira Vajpayee, so you can clarify all your query to Mr. Shivam. Shivam, I don't think so. They have
Okay.
any problem.
Okay, so
Ira,
that so we can just proceed with the today's session. So let me
yes.
just share my screen. Hopefully my screen is visible to all.
Yes, yes.
Okay.
It is visible.
Okay, so you all are must be familiar about the this Typhoon Hill Control Center software, has been installed at your system. And today in the session, we are going to just give you the demonstration and on the topic by the name of introduction of TIC 2000 toolbox packages. So till the time you have already experienced about the schematic editor, Hill SCADA, and the whatever the example sections you must be having. So the thing is that the once you click on this plus symbol by the name of the additional tool, you must be aware about the last option by the name of the package manager. So once you just click over the package manager, there is an option of a or the one first tab by the name of a marketplace where the list of the packages are available. So the what are the things the packages are going to be understand by you all It means whenever the Typhoon is team is working, suppose the one is so for the today's session only, the we are working on the TIC 2000 toolbox. It means that the TI means the Texas Instrument Controller card we are going to work on. So there must be some of the tools that is specifically designed by the TI users or the TI people, and that to be compatible with the Typhoon environment. So the in the collaboration of a Typhoon and the TI, both have just developed some package inside our software by the name of a TIC 2000 toolbox. So you can see this particular toolbox is already installed in my system, and whatever the details of over this toolbox is written over here. So as you can see, this toolbox is quite helpful for you once you are using this particular toolbox while using a different type of the controller cards or the launchpad interface that is being mentioned over here, that is starting with the 283790 or the 280049C or 280039C or 280025C and 280013. These are the launchpad interface. Launchpad cards are available by the TI, and the controller card like 283790 and the 28335. These are the two controller cards. These are the things are quite compatible with this particular toolbox by the name of a TIC 2000 toolbox. Now this is the things that is giving you the idea what are the devices are being supported by this particular toolbox. Again, what is the additional things we are getting while using this particular toolbox? So as you can go through the previous slides or the previous session, in which you must be aware about the auto code generation. So this particular toolbox is giving you the leverage about the thing by the auto code generation. That means you need not to go for the writing the complete code for the whatever the you are going to have for whatever the controller part you have been designed in the MATLAB environment or our Typhoon environment. Whatever the controller card you have been designed inside a Typhoon environment, the code associated with that particular controller logic will be automatically generated. Not only automatically code generated, it will be compiled and flashed inside the controller card or the launchpad you have been connected with the hill device. So what you need to do is you can just simply click on the install but I tab present on the right hand side, and after installing this, whatever the examples associated with this particular toolbox is automatically added inside this particular example tab. As you can see, this particular second last option by the name of a TIC 2000 toolbox example tab is available to me, and you can see the various example are being associated to this are available to me, and these all are ready to use. So you can just click on any of the example, and you can just by clicking on the open model, you are ready to use this pre-built example model inside the schematic editor, and you can learn more about the things. Again, if whatever if any of the toolbox or the package is requiring some of the additional what we can say the library component, these the component will be directly added inside the library section, so that we can also see in the coming time. So what we in the today's session are going to do is, so you must be aware about the devices by the name of a hill 101, hill 506, and the hill 606 and 404. So you must be aware about this. Again, this particular device, as you can see on the screen, is hill 404. Today we also going to use this device only. Again, along with this, you can see this particular launchpad interface board we are going to use. So the function of this launchpad interface board is to just give you the easy connectivity of whatever the controller card we are going to use based on the type of the launchpad interface board. So this particular launchpad interface board is a Hill TI launchpad interface board. So this is quite compatible for the whatever the controller card we have just seen, like a 283790 or something like that. We all these are the type of the controller card are compatible with this type of the launchpad interface board. So you can just easily connect it without doing much hustle bustle about the what type of the configuration or which pin to be just connected over there. So the if you just give you the idea. So this is the particular launchpad interface board will be looking like to you. So these are the pins that to be connected with the analog input output and the digital input output. Again, this is the pins where we are going to connect our launchpad sorry, TI controller card, and these are the BNC connectors for from where we can just give and take out the signals then that can be monitored over the our CRO if we are having for that. Again, you can just also have a look what type of the controller card or the launchpad interface or the TI launchpad we are going to use. So this is a TI based launchpad, that is the C2000 series 283790 we are going to use in our today's session. So we are starting with a very basic example and try to learn how to just start initiate with the just opening the model and how to just go for the just flashing the code and just to the do all the possibilities that could be done on the hardware setup and also on the SCADA panel. One more thing that I have already told you, that you need not to go inside much deeper for the what type of the steps to be mentioned or what type of the coding language you need to go with. So this is giving you the leverage of the auto code generation. So one thing that you must be after installing the package, two things you need to just use or install in your system, that is by the name of a C2000 warehouse software and the code composer studio software. Okay, so these two software you need to install inside your system, but you need not to open at any cost. You need not to open this. Okay, because we are going to just flash the code or generate the code from the Typhoon itself. So let's just begin with starting with the connecting of whatever the stuff we are having at our place. So just I'm just opening the camera of my another device and you can just see uh, just a second. Yeah, are you able to see the another camera? Are you able to see? Just pin this. Are you able to see the device? Okay, so this is a Hill 404 that we are going to use. Again, this is a launchpad interface board that I have connected. That is a Hill TI launchpad interface board that we are going to use. Again, this is a controller card that we are going to use. That is by the name of a our 283790. So I will just simply connected the analog input output and the digital input output pins of from this our TI launchpad interface board. For the connecting this, I have just using the simple the USB cable that could be connected with our system, and for powering it, I'm just using a simple connector to just power up the Hill device. At the back end, I can just show you if it is visible to you. At the back end, you can just see the red color button is available. That is for the our turning on the Hill device. And once we have just click on this turn on the device, you can just see the at the very front side, you can just see at the very front side there is an LED button is available. LED is available. So once it is double blink, it will be initiate that our device is ready to use. Let me just quickly just do the things and just turn on the device. Okay, just a second. Now I have connected my system with a Hill device and also connected the supply of this Hill device to the power. Okay. Now once I just turn on the device, you can just see the LED has been glowed. Okay, so after this, it will double blink. It will start to double blink after the 30 to 40 seconds. Once it is double blink, it will be ready to use. Okay, now you can just see the device has been double blinked, and we can just simply connect the our this controller card on the pins available on the very top of the hill device or the launchpad interface board. We can just connect the our controller card right over here, and we will be using this USB cable to just connect to or to just power up this controller card from our system. Okay, let me just do this thing also. Now you can see that once I have just plugged this USB cable of the which has been connected with this controller card, the LEDs has been start glowing. That is indicating that powering is being started to our hill device. Okay. Now just coming back to the screen and just set the whatever the things we are having. Okay, let me just share my screen again. Okay. Yeah. So once you already known that the LED has been double blink on which is present on the front panel of the HL device. So after this, you can just see that okay, my SCADA is already running. So it is a now good point to just remember that now whenever you are going to use this Hill device, the device manager will only detect the Hill device is active or not once the Hill SCADA is off. Okay, so I can just close the hill SCADA and now just again just see that whether my hill device is available to me or not. So as I told you that hill device is hill 404 is whatever the connection type we are using. It is a USB type of the connection. Its status is indicating the green colored symbol, which is indicating that it is available to be used. After this, the device name and the serial number, device ID, whatever the type of the configuration we are using, firmware version, and it is synced or out of sync is all the information is available on this particular detected devices section. Now, if you want to use this particular device, what you need to do is you need to simply select the Hill device. And after selecting this Hill device, you need to click on this green color arrow, which is directing towards the left hand side. Now, once you clicked on this, you can just see that the available device has been shifted toward the active Hill setups. Okay. Now, after this, we coming back to this example section where we are going to see that our Blinky project is available to us. We can just simply open this model by clicking on this open model section. So whatever the examples are available to you, each is coming with the three tabs. One is a open model, one is the application note, open application note, and the open test. Few of them, each and every model is open access. So you can just after installing the software, you can ready to use each and every example model, whether they are coming from the package or they are coming directly from the ones after installing the software only. Few of them are coming with the application note and few of them are coming with the open test. So let me just check whether it is opening or not. Just a second. Let me just. Just a second. Yeah, now it's starting to just opening the schematic editor in which we are going to just open our model. So this is a very simple example by the name of the Blinky model, or the Blinky project by the name. Okay, so in this particular model, what you are going to observe, you are going to observe the LEDs that are being present on the front side or on the top of the our uh, this particular TI controller card, or the launchpad that we are using by the name of a 28379D. So which is having a blue color LED that is continuously blinking. That it is continuously blinking because the previously flashed code is also that particular blinky model code only. Okay, you can just see that thing. It is already blinking. So again, we are going to use this kind of the thing only. Okay, so once after opening this schematic editor, you can just observe that we are having a one block by the name of a TIC 2000 setup block. Okay, now this is the only block which is giving you the leverage just to for the thing by the name, for the generating a code, for flashing the code, and for compiling the code. All the things are going to be done by the single click, by using this particular TIC 2000 setup block. Okay, now I have already told you that once after installing this particular package, you must be having some of the additional tools or the additional component that to be added inside the library section. So you can just see on the left hand side, we are having a library explorer in which the very last folder has been appear by the name of a TIC 2000 toolbox. Once you just simply drop down it, you can just see that we are getting a various type of the uh, blocks by the name of a ADC, or the ADC generic. We are getting for the communication, for the encoder, for the GPIO pins, and for the legacy component, for the TI library updater, for the PWMs, and simply and a simple TI setup to C2000 setup block. Okay, we are getting all the kinds of the things. Again, in this particular model, we are having this particular subsystem by the name of the Blinky. So this is our subsystem, and in which we are having some logic which is appearing. So what you are seeing over here, we are having a one constant block which is having a value of a continuously one, and which is being connected with a two blocks which is being named as a GPIO DO and the hill DI. Okay, so these GPIO DO is giving you the idea whether that whatever the value we are giving, that is a value one we are giving, that is to the our launchpad we have connected, that is a 28379D controller card. Okay, again, this hill DI is indicating the we are feeding back the value from the controller card to inside the our hill device, and we are allocating the GPIO pin number, that is GPIO 31 and DI1. So you can just double click on this and you can see that which digital hill DI number is indicating. So you can just scroll it down and you can select whatever the pin number you want to go for. After this, you can also use what type of the interface you have want to use. So currently we are using a Hill TI Launchpad interface board. So we have selected this by default only. You can also select the what is the pin action to be, whether it want to set the pin, or you want to clear the data, you want to toggle it, or you can want to control that particular pin. So you can just go for each and every action that could be happen or done by this. Again, if you want to learn more about what type of the things we could do with this particular block, so you can just have a help section that is present on the bottom, at the bottom on the left hand side. By simply clicking on it, you can see the complete documentation is being available to you, and you can just go through it, the documentation, and you can just learn more about it. Again, simply we can go for the again the pin by the name of a GPIO DO1, which is indicating that what type of the port we are selecting, whether the port A, B, C, D, or E port, what type of the action we are going to perform, and the what type of the pin number we are selecting for the GPIO. Okay, now coming back to this, Before doing this, now the one question may arise: how we can just identify how which pin number of the hill device is to be connected with the launchpad or the whatever the controller card we are using. So for this, we can just simply go back to the documentation tab, and where you can just see that I can just bring you for that also. You can just simply coming back to this Typhoon Hill website, and where you can just go for the product, and there is an option of a Hill TI interface cards, and after this you can just scroll it down, and there is an option for the Hill TI launchpad, and there is a very first option by the name of a read documentation. In this particular read documentation, you will be getting a complete description about this Hill TI Launchpad interface. Okay, so you will be getting the what is the overview. In this overview, you will be getting the what type of the power supply it should be having for the jumper wire or for the LED indication. What are the number of the digital inputs and the digital outputs, analog inputs and the analog outputs, and what are the level shifted voltages and the clamped voltages are available for this particular analog input output and the digital input outputs. You can just observe that kind of the things also. Again, if we go for the detailed description, in this particular detailed description you will be getting the idea what is the pins or the structure we are getting, how is what is its dimension, and what are the things are available like this analog connectors and the digital connectors and the measurement terminals, encoders, and for the PSU selectors, which is or the launchpad connectors or the monitoring BNC, whatever the things we are having, we can just select for this. Now this there are the certain tables are available along with this documentation, which will be giving you the idea about the which pin number of the hill device is going to be interfaced or linked with this particular controller card or the launch we are using, that is a 283790 or the 28069M or the 28027F. So you can see this is giving you the idea about the about the hill analog outputs, and for the controller card, that is 283790. So you can see analog output to 1 is directly going to connect with the ADCIN 14 pin of the controller card. Similarly for the 2, 3 and 4, you can just scroll it down and you can just learn more and more about it. Similarly, you can go for the digital connectors. You can just observe the what are the digital how the digital output pins are going to be connected with the controller cards pins like a 283790 and other controller cards are available in this particular table. Similarly, you can go for the digital inputs, and you can also go for the encoder connectors. Okay, now one more question arises, that how we can just remember this or how we can just identify by simply seeing the whatever the controller card we are having. So for this, we are having this particular diagram right over here, which is giving you the complete idea about the things that is present over the our controller card we are having. So you can just simply just go through this diagram, and you can just observe whatever the junction number, like a junction number 1, 2, 3, 4, 5, 6, 7 are present over here, and along with the junction number, the pin number is also assigned starting with 1 to 10, and what is the pin number of this junction is being allocated to, like a ADCIN 14 or ADCIN C3. Similar such kind of the things are present on this particular chart right over here. So you can just observe these kind of things, and you can just simply learn more and more about it, how to you can just connect it to your system. Okay. You can also observe what are the other supported cards are available in this particular documentation. So these are the supported cards are available that can be easily used by simply our this TI based launchpad interface board. And what is the position of this that we can say the ROE1 and ROE2, because this whenever the controller card we need to change these particular positions we need of the registers, we need to just enable or disable or from just to change its location. So on the basis of that, we need to just make a little bit modification in our launchpad hill TI launchpad interface board. Okay, so you can just go for that also. Again, we can just coming back to our this uh, model. So in this model, now coming back to this root window, we can just simply just click over it, and you can just observe. If I just double click, now it will be asking me about the uh, path of the Code Composer Studio and C2000 where. Okay, so it is so the thing is that whenever you are going to use this particular launchpad interface board for the very first time, or the control card for the very first time, it will be asking you this particular kind of the path. Okay, now it may also ask whenever you just change the software, or you may change the versions of the software, so it may also ask. Okay, so before doing this, I can just make one more change. That is the I will just see that it to be the detect the auto detecting settings. So the model has to be run on the 404, but the default by default settings has been for this particular example is being saved at a hill 402 at configuration ID number 4. So the thing is that we have connected the hill 404, that is the device number, and the configuration ID is 1 that we have already seen in this particular device manager table. Okay, I hope you remember. So in this device manager, you can just see the hill device name is the hill 404, while the configuration ID is 1. So we need to make certain changes in this kind of the things also. Oh, so I can just I have just by mistake I just close that. Let me just quickly open this. Okay, so these kind of the things we need to just make once we need to go for this particular before running the model. Okay, so you need to just go for these kind of the things. So this can be done in a very simpler way by you can just observe the whatever the configuration you are going to use for your model and what type of the device you are going to use for your system. So you can just on the basis of that scenarios, you can just check what are the things are available to you. It is in a few seconds we are ready to use. Okay, so once again we can just check, and we can have a option by the name of auto detect settings. Once I click on this, you can just see that automatically it has been detected the device name is hill 404 and the configuration ID is 1. Okay, so after doing this, I will just set up the path for the CCS and the C2000 where. So for this, I simply click on the browse. Now in the browse is I'm having a one folder by the name of a TI. So I will just simply search on this. Okay, in this, not in this, in the local disk C only. Yeah, this in the TI. I'm having this CCS. Okay, I can just simply select this folder. Okay, after this I want to use for the path for the C2000 where. So again I just simply click on the browse, and you can just see the I'm having this option by the name of the C2000 where underscore 5 underscore 00 underscore 00 I will be selecting this particular folder, and after this I will just click OK. Once I am clicking OK, it will be indicating the message at the bottom. You can just see that the TIC 2000 settings written successfully. Okay. After this, you can just observe in the general tab of this particular C2000 setup block, it is indicating the name of the particular subsystem, name of the project, and the name of whether we are going to use a CCS model path, and what will be the target platform. The target platform is indicating the what type of the controller card or the launchpad we are using. So we are using a not a controller card, we are using a launchpad Excel launch Excel by the name of a F283790. In this particular sorry, this particular TI setup blocks is supporting these kind of the launchpad and the controller card. You can just go through this also. After this, we can just have a second tab by the name of a deployment. In this deployment, you can just see the way are having a various kind of blocks or tabs are available. But the very first is by the name of the build and deploy, then for the create CCS project, then for the export code, then for the build and for the target. You can, if we just click on the create CCS project, it will be creating a code only. Okay, once after the code has been generated, if we click on the export code, it will now export the code. Okay, after this it will be building that particular code to that to be ready to be flashed inside our controller card or the launchpad we are using. After this it will target that or the flash that particular code inside the our controller card we are using. But if we are clicking on the build and deploy, all the process is being done by a simple single click only. So I will be clicking on the very first option, and let's just see what happened. I will be just turning on the camera also. You can just see. Now, once the flashing has been initiated, the blinking of LED will be stopped, and all the three LEDs, that is yellow, red, and this blue, all become stationary. And after the flashing has been completed, the blue LED will start to be blinking again. You can just see on my another camera section, it is being stopped. Now the flashing has been targeted completely successfully. So you can just see the message at the in this particular section at the very last, the target flash completed successfully is indicated. And now you can also observe before that, while the LED was stationary, that all the LEDs are not blinking. None of the LEDs were blinking. Now the blue LED is start blinking. Okay, so in the hardware setup we are getting the result that is indicating that we are getting the full proof result. Okay, and now what if we just do the things or just reading the data with the hill device. Okay, once I will just compile this model by simply clicking on this option by the name of a compile and reload the model in hill SCADA. Once as you already know that our device is already connected with our system. So the everything that is being simulated in the software now shifting from this particular software to the hill device only. So I will just click on this, and you can see that the process has been started of the compilation and for the loading the model in the hill SCADA. Once the model has been loaded in the hill SCADA and we are going to run the model in the hill SCADA, the LED of the hill device, that is the white color LED that is on the front side of the hill device, start to blink continuously. Okay, now this is a SCADA panel especially designed for this Blinky project. We can just start this model for the starting the simulation, and before starting it, at the bottom you can just see that it is indicating the real time mode. Okay, so this real time mode is indicating that whatever the simulation we are going to run is in the real time. Before this, in the previous sessions, you will be running all the things in the virtual hill mode only. Okay, and before once the SCADA appear, it will be indicating a message that whether hill device is not detected, whether you go for the virtual hill mode or not. So this kind of the message doesn't appear in today's session. So let me just click on this green color play button and start the simulation. So it will be giving you the idea that the blinking of the LED is continuously happening as per this pulses are being uh, increasing or decreasing or just appearing. Okay, but the LED tab you can observe on the screen right now, it is not appropriate with this particularly the what we are getting the waveform. This is because this LED is going to be running on the CPU of the HL device, while this waveform that we are getting is according to the FPGA controller card we are having. Again, I can just show you that the LED of the hill device is also continuously blinking. You can just see on the another camera I'm having. So the LED of the hill device is continuously blinking, while the LED of the this controller card is also continuously blinking. This blinking of the LED of the controller card is correspond to the whatever the waveform we are getting on the SCADA panel. So till now we have seen very a simple example, and you must be now seen that it is quite simple to just without going much deeper inside the how to write the code and what should be the coding part to be done. We have simply just created the code for this particular subsystem, and by the simple click we have just flashed this control logic inside the controller card we have connected. Now we just simply just open one more example to give you the much more detail. So we are having a one example by the name of a buck converter. So I will just open this model also. So this is our one more model we are having, and this is having a one subsystem by the name of a open loop, and this is a complete buck converter model we are having, which is having a source, DC source, pre-built or the pre-packed buck converter that can be you can easily drag and drop from the library section, inductor register that is being ESR, that is a equivalent series register of the particular capacitor, and then some measurement component for the current and the voltages and the load that is connected. Now coming inside the this open loop subsystem block, we are having a one SCA setup block. It is this SCA setup block is being used for setting a communication between the hill device and our controller card for just to generating a duty cycle or the PWM signals that could be sent and received between the hill device and the controller card. So this kind of the logic we are doing. So again we are having a TIC 2000 setup block. Again we just double click on this. Now you can just see in the previous example, once I have clicked on this TI setup blocks, it was asking me to have a path of the CCS and the path of the C2000 where, but this time it won't ask me. It will be directly giving me this particular interface, which will be having a general tab in which the name of the particular subsystem, project name, it is has been using, whether we are using a CCS path, model path or not, and what type of the controller card we are using. Again we are having a deployment, then scheduling that is being on the execution rate based on the CPU timer, and the whatever the settings that is indicating the whatever the path for the CCS and the C2000 where. Okay, again coming back to this, we can just again click on the build and deploy, and you can just observe what will be going to happen with this particular blinking of the LED. Now, the previous example was related to the blinking of the LED. That's why the LED was continuously blinking. But this example is not associated with the blinking of the LED. So once the flashing has been completed, so the blinking of the LED will be stopped. So now it is indicating that the target flash has been initiated. So once it is completed, so we are ready to run the model, and we are going to the SCADA panel. So now the message has been appear at the bottom. You can just see the target flash completed successfully. And now you can also observe in the previous example, the after this message of the target flash completed successfully appear, the blinking of the blue LED is appearing. But in this scenario, it is not. Okay, so it is has been mentioned on the screen that disable the subsystem before compiling the model. It is suggesting because we have already flashed the control logic inside the controller card, so we need not to go for this particular control logic. So we will just right click on this and click on the disable the selected model item, and after disabling it, we will just click on the compile and the reload the model. You can just open the SCADA panel associated with this open loop buck converter. So this is the our exam model SCADA panel associated with this open loop buck converter. So you can just see there are the few more blocks has been appear to you. So there is a one SCA setup blocks. So this particularly for the communicating the hill device with this our controller card we are using. So it is indicating the what type of the COM port we are using, whether we want to connect or disconnect, what should be the baud rate, what should be the stop bit, what should be the time out and priority. So you can, if you want to learn more, you can simply double click on it. It is logged, so you can just double click on this, and you can just go to the help section, and you can just learn more and more about this particular block, what is it indicating. Okay. After this, we are having a SCI write block. So it is will be associated with the what type of the message or the what should be the value we are going to just pass on through with this control logic. Again, this is an image of the whatever the model we have already used, and these are the digital display for the source voltage, output voltage, and the output current. So starting with this, first of all, we will just connect this, and we can just run the model, and we can just observe what are the things we are seeing. So this is a buck converter, so it will be giving you the low value that should be appearing, over this. Okay, so I have just mentioned the value for this 0.9. Okay, so as per this, the 100 volts we are giving as an input, but the buck converter is stepping it down to the 90% of the input value, that is approximately 89. Okay, similarly we can, if we just go for the 0.5, okay, so it will be giving you the around 49 or 50, something like that. Okay, so this is the actual buck converter we are using with. Okay, Now, no effect will be coming on this particular LED, because there is no relation between the what is the LED. Only the controller logic we have just dumped inside this particular launchpad we have used, but the LED of the this particular hill device is continuously in blinking. We can also change the value with what happened if we go for the 1. So it will be giving you the complete, no, no depreciation. Okay, what happened if we go for the 2? Again it will be giving you the same 100, because it is a buck converter, so we cannot go beyond the 100 volts. We can go with the decrement only, because it is the buck converter only. So let me just toggle the full screen. So hopefully you all have understood what we have done with this particular launchpad we are having, and the TI based package we are having. So you need not to go for the coding section for this. Beside this, if you are using any other type of the hill device at your end, you must be known for the first you build the control part in the inside the software, then you just create a code by using some sort of the code composer studio, and after this you will be using the some sort of the flashing software like a uniflash or the wireshark to flash this particular controller logic inside the controller card. And after doing such type of the big exercise, you can only be able to just use that particular controller card that could be connected the whatever the hill subsystem you are having at your end, to test this various kind of the scenario. But if you are using a Typhoon Hill product, so you will be having a leverage to have to use these kind of a package that has been already being developed in collaboration with the TI Texas Instrument, and in where you are not go inside the section of generating a code or writing a code, and after this flashing the code, you have a one block by the name of a TIC 2000 setup block, where you can just easily uh, flash the code, you can generate the code, and you can just ready to use that particular controller, and you can just ready to just go for the various kind of the testing at your end. So these kind of the things can be done with the use of this particularly the TI based controller card. So you are having a different kinds of the examples with us. You can just go through them, and you can just have a look how the uh, uh, what type of the components they have been used, and what is the specific use of that particular components inside our system. Similarly to this, we are having a various kind of the packages, so you can just go through the other packages also, and that could be used by the various kind of the environment or the various kind of the systems in the market. Okay, if anyone having any query, they can just ask. Anyone having any query? So after this, what else we can just learn about the this particular exercise today is that what are the things we can just also do with this particularly TI based controller card we are having. So the thing is that you can just also go for the exercise like what happened if you just change the pin number that is being associated with this particularly the GPIO pins, and how you can just change the port level you are having, or what happened if you just change the actions of the to that this from toggle to the set, or from this to the clear pin or the control the pin, such kind of the things you can just use that kind of the scenarios. And also you can just have an option to just change the hill DI number, and you have available with this particularly the measurement terminals available at the at every launchpad interface board, so you can just connect your um, your what we can say, your multimeter and your oscilloscopes right over here, digital oscilloscope, and you can observe the readings what is coming from the hill. And you can also observe the allocate the pin number which is giving you the output of this particularly the controller card. So you can just validate those kind of the things from the oscilloscope also, and from the multimeter also. You can just observe the waveform on the multimeter oscilloscope and verify the whatever the waveform you are getting on the typhoon website, whether they are correct on the oscilloscope or not. So you can do this simple kind of the exercise at your end also. So this could be done. Again, if you are using the kind of the buck converter model, so you can have a leverage to just create the whatever the open loop model they have created. You can just go for the creating a different type of the logics could be developed at your end by the name of a closed loop or the various type of the algorithm. You can just apply to this, and you can just have a kind of the exercise where you can just start with this scenario where you can just observe the things, and you can just check what is the specific observations you are have getting after changing the certain kinds of the things. So if I just did double click on this, you can just see it is mentioning that it is having a execution rate of a ts and the time out of the zero point 0.1. Again, it is mentioning that the what is the data is being a variable we are getting, so it is getting the duty cycle only. You can just assign the number of the variable. If you just change the number of the variable, you can just change the what up of the variables you want to get out from this particularly the SCI receipt block also. Again, if you want to go for this PWM section of the EPWM section, so where it is indicating the which number of the channel is getting the data from the control card or to the hill device back. So this kind of the things you can just select those pins, and you can either you can just select the uh, if I just go simply go back, and if I just select for the data, and you can just select the variable number 2. Okay, after this you can just see the 2 after clicking on the 2, it is indicating the number 2 is appear to you. And you can just see that what will happen if you just double click on this, and you can just see the which number of the pins should be you have to allocate you. So you can just select the number of the channels right over here. You can just after selecting the number of channels, you can just go for the what are the number of the pins, or the pair of the pins you can just use inside your environment. You can just go for that also. Again, you can just go for the whether you want to enable the ADC triggered, or what happened if you will interrupt the enabled signal. So the whatever the event or the timings you should be having, whether the counter should be equal to 0 or equal to the periods or equal to the 0 or periods. Such kind of the scenarios you can just apply for. Or you can go for the when it should be interrupted, or the whether the trigger ADC on, whether the it should be the at every event or every second event or every the third event. You can just select these kind of the scenario. So this is up to you how deeper inside the things you are going to go for and analyze the things. It's up to you. So these kind of the things we can just go for. Again, coming back to the SCADA panel that we are having for this particularly the uh, buck converter. So this kind of the things we are having like so we can just go for the it is not going for the like this. We need to just parameterize all the things. It is a pre-built component that is inside the uh, library section, where we can just simply just having a block by the name of a TIC 2000 toolbox, where we are getting components by the name of the hill SCI read, SCI setup, and SCI write. So we can just simply drag and drop those components inside the SCADA panel, and we can just use those kind of the things inside our environment. So these kind of the things we can just go for. So This could be the discussion for this particularly the TI setup section. So if you are having any of the query, you can just ask, or you can just drop the things inside the uh, chat box also. So we can just have a more discussion if you are facing any kind of the query related to this particularly the session by the name of a introduction to the TIC 2000 toolbox package. Okay, then we can just have a break for 5 minutes, and after the 5 minutes, we can just resume again. And for in during this session, in the coming session, we will be going to just have a look on the demonstration of the examples related to the V2G and the G2V configuration for the electric vehicle, where we are going to just discuss about the charging infrastructure of the system.
Dear participant, I have already shared the link to you, and the second session of Shivam Saab would be start at 5:15. So over to you, Ronak. You would like to conclude this session.
Yes, sir. Sir, am I audible? Sir, am I audible?
Yes, Ronak.
Yes, yes, you are very much audible,
Okay.
but your
Okay.
video is off.
Yes, sir.
Now it's
Sir, thank you so much, sir, for your informative and knowledgeable session. Now we will take a short break of 10 minutes to refresh ourselves. I request everyone to kindly be back by 5:40 p.m. 5:20 p.m. 10 or 20
5:15.
minutes.
5:15, Ronak, we will start because the second
Okay.
session has to be wind up before 6:30, right? Because we will start valedictory function at 6:30, and their feedback session will be there, so it would take another 1 hour. So everyone, please
Okay.
come back before 5:15.
So we will be back by 5:15 p.m. So we will continue then.